Okay, in this video we're going to look at a previous exam question where we are given two functions, f of x and g of x, and in f of x there's an unknown parameter k. And we're told that the graphs of f and g intersect at two distinct points, and we're asked to find the possible values of k. So first thing we need to do is think about what does it mean that they intersect. Well, if the graphs intersect each other, it means that for some x value, the value of f and the value of g will equal each other. So we are basically looking for something like this: f of x equals g of x. And we're told this will happen at two distinct points. There are two x values that will make this happen. And I'll rewrite this just using the definitions. So we have kx squared plus kx equals x minus 0.8. And this is starting to look like a quadratic, but we would like it in the standard form. So I'm gonna rewrite it and just move everything from the right hand side to the left hand side. And we'll get kx squared plus kx minus x plus 0.8 equal 0. And finally, to get it even more standardized, I'll collect the x terms and write it as kx squared plus x times k minus 1 plus 0.8 equals 0. Now this is a quadratic in standard form, in using x as a variable, and we have some unknown coefficients. But we know that this quadratic is supposed to have two solutions, two distinct solutions. So if we can calculate the discriminant, it might help us. And the discriminant we know we'll get from the standard form, so I'll just write the standard form underneath as a sort of reminder how it looks. It's supposed to be ax squared plus bx plus c. And why did I do that? Well, it helps to identify their coefficients. So we have a, in our case, equals k, b equals k minus 1, and c equals, therefore, 0.8. So we remember the formula for the discriminant. The discriminant, symbolized by capital delta, equals b squared minus 4ac. Or in our case, delta equals b squared, so that's k minus 1, everything squared, minus 4 times k, since a equals k, times 0.8, since c equals 0.8. And after a bit of rewriting, we can get, I'm skipping a few steps here, but we can get delta equals k squared minus 5.2k plus 1. So this is a discriminant in what I would say is the simplest form, and we want it to be greater than 0. So we have a new inequality with a quadratic using k as a variable. There are two ways of doing this, or solving this, and we'll look at both of them. But first, we'll just look at this expression and think a bit. Could we make a sketch of it? Well, we don't know the value of k, but we know in this quadratic we have no coefficient in front of k, so it's going to be open upwards, the graph of this function, or the discriminant as a function of k. we also know it will have a line of symmetry, or an axis of symmetry, at a bit to the right of the y-axis. We don't need to be more specific than that. So it will look something like this. And we are looking for the parts where it's above the x-axis, because we want the discriminant, that this is the graph of, to be greater than 0. So we want to exclude this part. We can do that if we find the two x-intercepts, or well, k-intercepts I suppose I should call them. There. The zeros of this quadratic. And we can do that in two ways. One is to use a calculator. So we enter this function, and now I'm going to have to use x as a variable, which might be a bit confusing, but it's what it is. So we have x squared minus 5.2x plus 1, and we look at it. We see that it looks a bit like my sketched graph. That's good. If we zoom in a bit, we can so we see that we have two distinct k values for which the discriminant will equal 0, and between them, between those two values, the discriminant will be less than 0. But we want to find those borders, and on this one, on this calculator, we use that by going to the calc menu, finding the 0. And we asked for a left bound. We can trace it, or we could have inputted it as well. So there, go to the right, no need to guess. It says x equals 0.2. So this one, this k value equals 0.2. And similarly, we can find it's around 5, it seems. So calc 0, left bound say 4, right bound 6, guess, yeah, 5, exactly 5. So this intercept is when k equals 5. And therefore we have actually solved it. We have an answer saying that if k is less than 0.2 or k is greater than 5, any of these two will lead to the discriminant being greater than 0. And since the discriminant is greater than 0, the discriminant of our original function, this function, that means that this is true, and therefore that f of x and g of x will intersect. So we might also want to be able to solve it a bit more analytically. I mean, we should be able to use some algebra techniques to find the solution. Supposing we didn't have a graphing calculator, what would we have done? So we come back to wanting to solve then. We're still looking for the intercepts. We want to solve k squared minus 5.2k plus 1 equals 0. And we still know that this will give the boundaries, and we're looking for the interval between the two k values. So we apply the quadratic formula. We say that k in this case will be equal to 5.2 plus or minus the square root of 5.2 square minus 4, everything divided by 2. Yeah, it doesn't look all that neat, but it's gonna sort itself out. This will be equal to 5.2 plus or minus the root of 23.04. I think we're going to use a calculator at some point. Divided by 2. And this actually turns out to be 4.8. Aren't we lucky? So it's 5.2 plus or minus 4.8. Everything divided 2. Which gives us in the end 2.6 plus or minus 2.4. That is to say, our first k value, k1, equals 0.2, and our second k value equals 5. And luckily we arrived at the same result. So we have again found the boundaries, and between those two values the quadratic will be negative, the quadratic in k, so the discriminant will be negative. So between those two values there will be no real solutions to this equation. That is to say, there will be no intersects between f and g. You might wonder what would happen if k was exactly 0.2 or exactly 5. Well, the discriminant would then be 0, which means there would be only one solution to this equation, which is the same as saying that f of x would touch upon g of x but not cross it, and that happens for two values of k. It might also be worth to point out, so in our final answer we write k less than 0.2 or k greater than 5, but we should possibly, even if it's not mentioned in the mark scheme, point out that k should not equal 0. Why? Well, because then it stops being a quadratic. If k is 0, then the whole f of x turns to 0, and we have a question of a linear function equaling x. That will intersect at one and only one point, so it doesn't fulfill the conditions. That's not mentioned in the mark scheme, but it would give an extra star point, I think, if you find it. Hope this was helpful. Watch it a few times and try to follow the steps, and we'll go through it on the next lesson. Thank you for listening and watching.